Hey everybody, and welcome to something of an unusual Let's Look At. This is Let's Look At Universe Sandbox. Now, we've been saying there's been a lot of unusual Let's Look Ats recently. It's true, this one is more unusual than most, because this is not a traditional game in the strictest sense of the word. This is almost, it's like a half game, half almost like scholarly educational tool that you can use to simulate either our solar system or our galaxy, or just various interacting planetary bodies or celestial bodies of your own choosing. This I picked up on sale in the Steam sale. It's been on my radar since it came out I guess it was about a year and a half ago. And it usually retails for $10, but I picked it up during the sale for $2.50, and it goes on sale all the time. And I figured, you know what? This is a weird and wacky game, so it might be an interesting thing to take a look at over the holidays. And maybe if you find it on the cheap in the sale, you might be interested in picking it up as well. So, basically, where we're going to start with Universe Sandbox here is, I'm not sure how this game is going to interact with Fraps, because it is a little bit computer intensive depending on what kind of stuff you insert into the simulation. But we can start just by loading up our own solar system here, and I can introduce you a little bit to just the interface of Universe Sandbox here. So by loading up our own solar system, basically if I zoom out here using my mouse wheel, you can see all of the largest bodies, or the largest like 35 something bodies in our solar system. So as you can see, if we zoom in, we've got the sun there. And then in order of the planets, we've got Mercury, Venus, Earth, Mars, Jupiter, Saturn. Where's Saturn? Zoom out a little bit. Saturn. Uranus is going to be over here. Neptune and Pluto, which is now a dwarf planet, obviously, but I can't get it out of my head. So you actually get like a real sense of scale. This is like the first thing that wowed me when I looked at this game, is you get a sense of scale of the universe, because you zoom in and you're like, okay, there's the 3 inner planets, and occasionally you can see Mars coming through here as well. But you really have to zoom out a substantial degree to get Jupiter in there, and then even beyond that, you have to zoom out a little bit more to get Saturn in there, just to give you a minor sense of the insane scale of only our own solar system here. But there's also all these other interesting things floating around here that I was completely unfamiliar with, like this trans-Neptunian object, 2004 SB60 here. We can just zoom in on that and be like, what's up, 2004 SB60? Good question. All right, I am in a weird position here. I can't zoom out. So let's zoom out. There we go. Okay. So by double-clicking on any of these objects, we can zoom in on them. So let's maybe focus on the sun here, and we can zoom in and be like, oh, so what's the sun like right now? The temperature is 5,778 Kelvin. That's pretty damn hot. We can see like mass is 1 sun, obviously. Density is 1.39 million kilometers. What if we went to Earth? How's Earth doing right now? Temperature, roughly, you know, it varies usually between like 16 and 18 degrees Celsius. Oh, I guess it gets as low as like 12 at some point. But anyway, the premise of, or the main draw for Universe Sandbox is not just being able to see these stats, although this is cool, and obviously this is going at a substantially increased like time step here, like every second equals 1 day or something like that. So 365 seconds is a year. Actually, it's got to be even faster than that, because it's making 1 full rotation around the sun in like 10 seconds here. But in any case, the main draw of Universe Sandbox, at least for me, is effing things up. So we could be like, okay, we got Earth here. What would happen if we just changed the mass of Earth? Instead of being 1 Earth, it actually weighs 1 Jupiter. Let's see how that would mess with things. So now Earth is substantially heavier, and we're going to see how that changes things over time here. As you can see, it looks like everything, at least just to start here, is getting much, much closer. And it actually seems like maybe the Earth's orbit around the sun has decreased a little bit. Or sorry, slowed down a little bit. Or maybe it's sped up a little bit. It's hard to tell. We could actually speed things up even further here. Maybe instead of 1 day, we'll do like 5 days per time step. And that'll make it go even faster, and we can see like long-term implications of this. Like if in 10 years or something, the entire solar system as we know it would completely collapse. We can see a lot of intersecting orbits here. I'm wondering if Mercury or Venus is ever going to have a decaying orbit now and somehow end up in the sun or something. As you can see, again, we've got kind of like a corkscrew effect going on here. What if we made it, instead of 5 days, 10 days? That's 1,000 days, I think. That might not be good. There we go, 10 days. Sped it up even more. Well, it doesn't seem to have too drastic implications. Let's actually slow it down to 1 day again. I just want to check on something. How does Earth fare now? What's its temperature like? Focus on that. Temperature, it's still doing pretty good. It's getting a little bit closer to the sun during some parts of its orbit, which is bringing the worldwide temperature closer to like 30 degrees Celsius, which probably has wide-reaching climatological impacts that I am completely unfamiliar with. I don't know if it's changed too much. Now that we've effed things up substantially here, what if we just change the Earth to be actually the mass of 1 sun? How would that mess with things? And again, we're going to switch this back to maybe 10 days now. And as you can see, this substantially changes things. The Earth is kind of spinning in on its own orbit around the sun. They've got like a helical orbit here. And the rest of the solar system is either coming with them or being left behind in the dust. Looks like Uranus is going to F off. Mercury's still well within the orbit here. We can also change the way these vectors look based on, say, their velocity, like this, or based on their density or mass. Let's make it vivid, see if maybe we can see a little bit better that way. Well, not really. But as you can see, basically we've messed things up here. We're going to just go back to our menu, and we're going to load up our own solar system again. And we're going to change things this time. Well, sort of as I expected, Universe Sandbox has crashed fraps, and that's probably going to happen a couple of times. It might require some editing to stitch together these segments here, but I want to continue showing it off because it is a game that has the potential to not only educate, but also entertain in its absurdity. So we can also, let's just go back into our solar system here. The last thing we did was make it so that Earth first was the same mass as Jupiter and then the same mass as the Sun, and that caused all sorts of weird and crazy effects with our galaxy. What we could also do, or with our solar system, I should say. I apologize, I will mess up that that nomenclature from time to time. Anyway, what if we just took the sun here, and we decided that we were going to make it a black hole instead? How would that change things? So we've changed the diameter of the sun, so its escape velocity is now equal to the speed of light. You can see Mercury seems to be entering potentially a decaying orbit. Again, we'll just crank up our time speed here to like 10 days. See what happens over time. Because obviously this stuff does take a little bit of time to actually make happen. We could actually probably make this 1 year if we wanted to. Oh god, Mercury is just shot through the event horizon, I think. And Earth and Venus just spinning around like crazy. I think things are gradually decaying here to the point where eventually they will get sucked into that black hole. It's hard to tell, though. It might take a period of several years before that's going to happen. So we could actually make this like... I guess we can just crank it up here if we wanted to, but I don't want to do it like that. I want to do it like this, like 1 year. Okay, well, obviously that has completely messed with things. I can't even tell what's going on anymore. But yeah, as you can see, like planets are slowly getting shot out of the event horizon of this black hole, I guess. I'm not really sure if that's how black holes work, but obviously Jupiter's orbit has decayed to the point where it is about to be sucked in. We don't want to be there in 2650 when this actually comes to pass. We're going to stop this. We're going to try to reopen a different simulation, maybe. Why don't we just open the Earth and Moon simulation here? And we're going to see if this doesn't crash Universe Sandbox, which I hope it doesn't. So we're going to click Earth and Moon. Good. Okay, so this is a bit of a more laid-back simulation. We've just got the Earth as well as our existing moon. Now, what we could do is just watch things. Let's change it to vivid colors here. And just change things again, like change the mass of the Earth. I guess we could change the diameter of the Earth as well. Perhaps to the diameter of Jupiter. And then the moon will just crash into us. Maybe we want to reset that right there. I did not expect that to happen. What if we just change the mass of the Earth again to the mass of one Jupiter? That is also going to suck in the moon. What if we... I guess I didn't change the density, so that might affect it. That might be expected. I basically turned Earth into Jupiter. Let's change the mass to one moon and then see what happens. So how does this affect the moon's formerly circular orbit? If we change our time step to maybe 1 day, you can see the moon is just like F you Earth. So we can load back into it here. Basically what I'm trying to get at is this is a good tool for experimentation. Basically I was thinking like if you're like an amateur scientist or astronomer, or you have a passing interest in science or astronomy as I do, this is kind of an interesting tool to play around with and be like, okay, what if the world was very slightly different? How would things change? Again, we're going to change our time step here, and we're just going to see the orbit of the moon. And we're going to wait for it to do one entire orbit here so that we can kind of get a feel for how things will change. What if we just changed the mass of the Earth and we actually just made it a little bit heavier? What if we made it like 1.25 Earths, which will obviously affect the orbit in some way here. I'm not sure if the orbit of the moon actually changes on a, I'm not going to say daily basis, but on a regular basis. But as you can see, it appears that the orbit of the moon is actually going to get, it looks A, slower, and B, much, much closer. We can speed this up just a little bit, maybe to 1 hour, and we'll see how this affects it. I wonder if it would actually decay. If our Earth was just a little bit heavier, would the orbit of the moon actually decay to the point where it crashed into the Earth? And this might seem like a silly question to those of you who are actually studying this professionally or scholastically, but, you know, forgive me as someone who is merely an amateur here. Let's change it to a day because it's not going fast enough for me. And it looks like it's got a relatively stable orbit there. If it's going to crash into the Earth, it's not going to do it for a little while. Let's just zoom in here and see what's going on. How you doing, Earth? I mean, the moon's still trucking here. So I think that's fair. What if we change it to 1.75 Earths. So we add like another 50% of the original Earth's mass. Again, seems to have kind of a weird orbit, but eventually maybe it doesn't reach something resembling a stable Earth. You know, it doesn't look that crazy. What if we made it 4 Earths? I think at that point the moon would just decide to crash in. Like so. Yes, or the moon's just like, see you later. And it travels very quickly. Another cool thing with the simulation, by the way, is if we just load up our solar system here, it has a really good way, and it also has like this list, as you can see here, of like fun things to do. This actually teaches you how to use the Sandbox. So this is a fairly powerful tool, and I'm only using a very brief, very minute aspect of it. But the fun things to do does a very good job of actually teaching you the basics of how to use what looks like a very complicated interface here. So in like 15 or 20 minutes, you can get a very good handle on how to change things. Like, for example, let's just put this away. I could just change our gravity here. Like, instead of having gravity at its normal constant, we could make it 1% or, you know, 50% crazier, and then see what happens over time. So if we change our timestamp to, you know, 2 days or something here, you can see what happens. And eventually, if gravity was twice as strong, you can see that it looks like our solar system would compress a great deal, which makes a lot of sense. In fact, if we crank this up even further, my guess is that, yeah, all of these will eventually just crash into the sun, and that will be the end of the universe as we know it. Although Mercury's making a pass for it. There it goes. Well, not the end of the universe, I guess, but the end of our time in the universe. You can see these all coming towards here. But again, we'll reset our solar system here, because what I want... Oh, God! What have I done? What I wanted to show you is that this simulation is a really good way of actually visualizing the speed of light. So if we actually come down here and we change, like, 1 real second equals 1 second, like, if we make it real time, this is the actual speed at which our solar system orbits. So if I do something like go to Earth... But let's do it with the sun, actually. So we'll zoom in on the sun. I can click on this button down here, which is actually emit a light pulse. So this will emit a pulse radiating out from the sun at the speed of light. So if I click this, it should start sending out... Yeah, you can see that's the actual, like, real representation of, you know, 5 seconds from when I clicked it, where that beam of light would be. So we can actually do this from the sun, and then basically just sit back and time it and be like, okay, how long does it take this ring of light from the sun to reach all of the planets? This is a really good way of visualizing the speed of light, which is something that is obviously so astronomical and quick that it's impossible to visualize under normal circumstances in all likelihood. So it's already been like 30 seconds and it still hasn't reached Mercury. Of course, for anyone who's you know, studied this even on an amateur level, you know that it usually takes about 8 minutes, I believe, for a pulse of light or a beam of light to reach the Earth from the sun. So if we actually change this to 8.00 minutes... Oh, let me do it, please. I've got to get my mouse off the screen, maybe. If I change to 8 minutes, then every pulse should reach the Earth in 1 second. So we can roughly time that, like, 1 Mississippi. Yeah, it seems pretty good. So that's pretty crazy. If you watch it in real time, it can get boring really, really fast. But it's also cool in that you can, like, okay, every 1 second is 8 minutes. It's still going to take, like, 10 seconds or more, maybe even 20 seconds for light to reach, you know, the outer planets here, like Uranus and Neptune, and of course the dwarf planets Pluto, even longer. Which is really crazy to actually, like, not only be able to see that and know that, because you can just learn that from a textbook, but to actually be able to control it and watch it happen yourself is a really neat way to learn. I think this could be a really cool tool, not just as like a game or something to mess around with, but as a, you know, a tool for like elementary or middle school students, or even high school students, who just want to kind of get a sense of scale for how big the solar system and the universe at large is. Hey everybody! We had another crash when we were recording Universe Sandbox, unfortunately, so we're going to have to wrap this up fairly quickly, because this game does not interact well with fraps in my video card. It's not Universe Sandbox's fault. By all accounts, this program has been reliable when I'm not recording. It's just, I think there's a lot of stuff going on all at once when you are recording with fraps as well, because both of those tend to be resource intensive. Mind you, we are using a very beefy machine here. But still. Anyway, the last thing I wanted to do, but I don't think we're going to be able to really do, because it crashes every single time, is create our own simulation. So what I was thinking is that we would actually create an empty solar system, or an empty piece of space that we would create our own solar system in, and we would just hypothesize that what if we changed, like, the closest star to us wasn't the sun, instead we made it Alpha Centauri A, and I was going to see how that would work. But since that is apparently too much for the system to handle, why don't we just load up one of these cool pre-made simulations that we can see, like, for example... collision with Jupiter. So I can show you that you can indeed basically just like fire asteroids at Jupiter if you so chose. I think if we go to this right here, maybe not. Physical properties, we could change its mass. I don't want to get involved in that. Oh, this is what it is. Okay, this is basically just asteroids colliding over and over with Jupiter. We don't actually have to shoot them. We have all these Shoemaker levees here, and the levees are about to break. Break Jupiter's ass, that is. So there's all sorts of cool, like, pre-made simulations that you can do and kind of just watch what would happen. What would happen if, you know, like 50 asteroids just all of a sudden collided with Jupiter one after one? Well, we will see here. We should probably increase the timestamp a little bit, maybe to like 4 minutes, just double the speed at which this happens, so we can see what happens. Here come the first ones. Basically, Jupiter is just a beast and keeps absorbing these. But anyway, I think that's going to basically do it. We can zoom in a little bit if we wanted to, but I think that's going to basically do it for our look at of Universe Sandbox. I'd like to show more, but unfortunately technical issues are causing some few problems. But needless to say, if you have a passing interest in science, or maybe you're an educator who is looking to kind of pique the interest of your students, this is an interesting game to show off. I think kids are going to have a lot of fun playing around with this. I'm not a kid, and I have a lot of fun playing around with it. And I think it's just kind of a weird game for Steam. It's not really a game, it's more of an educational tool, and I like it. It encourages experimentation and letting your imagination flow. But in any case, thank you guys for watching. This is Universe Sandbox. Hopefully you can pick it up for cheap in the Steam sale if you're watching this. But if not, regardless, thank you for watching, and I will see you next time.